Hey guys, let's find out how we can use the equation for the line of best fit. But remember, that straight line is still going to have a slope and a y-intercept. So the m in that equation, we know that that is an abbreviation for the word slope. You can also think of it as like the step number. M is the one-letter abbreviation. The b in that equation and also the sign in front of it, that would be our start number, or the real name would be the y-intercept. So when we take a look at the data that's down here, the height and weight of several different adults, you've got your height in feet, and then you have your weight in pounds. We understand what's x and y, and we could go and make a scatter plot. And it's kind of hard to see these numbers right here. So if you want to go and write in, the 150, the 100, the 50, and then by your height up here in the feet on the x-axis, you can do that. But please notice that the line of best fit, this straight line that's sitting through there, right? That red line that's through there, it is a straight line. So the 49.9x, that's about 50. So that means that your slope would mean go up 50 and over 1, up 50 and over 1. So if we looked at this part right here, if we can go up about 50 and come over 1 block, there it is, up 50 and over about 1 block. And that's what's happening there. So our slope really is about 50. Now, the y-intercept has that negative 134, and this is 0 right here. So if we ran it all the way down here, we'd be hitting at about negative 134. It's actually off the screen here. I need to go down further. But both of these things that we're used to using is true with this red line. Okay, we're just not showing you the whole graph. Now, how can we go about actually using this? Well, it says it was discovered that this can be modeled by the equation y equals 49x minus 134, where x is the height in feet and y is the weight in pounds. What they literally did is that they gave us the exact equation for this line of best fit that's slashing through the scatter plot. And that's very, very useful for us, especially because they said x is the height, right? Now, using this model, what would the weight of someone be who is 5 feet, 5.3 feet tall? Well, using the model is referring to the equation. So somewhere on your notes, let's go and write that equation in there. And then let's look at the information that they gave us. They said, what would the weight be of someone? Well, look at your scatter plot, or you can go up to the table a little bit higher. I noticed that the y-axis is weight. So that means in my equation, the model, that y has to represent the weight. Now, the height, the 5.3 feet, how do I know that that's the x? Well, look at your x-axis. Your x-axis says that's the height. Okay, so that x is going to represent the height. And if they want to know the weight, all we have to do is plug in the height that they gave us. So this 5.3 feet tall person, that's the height. We're going to replace that x with the 5.3. You pull out your calculator, and literally you just say 49.9 times 5.3 minus 134, hit enter, it follows through the order of operations, and you will get what your y is, which is your weight. Now, we get 130.47, or 130 and 47 hundredths. Remember though, it says round your answer to the nearest tenth, so that 7 tells us to round that 4 up to a 5. So as a result, a 5.3 foot tall person would weigh about 130.5 pounds. Let me fix that T real quick. There we go. Now, let's take a look at the scatter plot though. Let's go back up here to this, right? We know that this line of best fit matches up to this equation. But does this scatter plot show us that a 5.3 foot tall person really does weigh about 130.5 pounds? Well, go to where you think 5.3 is on your x-axis. I think it's about right here. And then I'm going to go straight up until I hit my line of best fit. And then I'm going to go all the way over to the y-axis. And this is above the halfway spot between 100 and 150. So the halfway spot's about 125, probably right about here. And you go up just a little bit more, I think that the scatter plot line that we have graphed there is exactly right on the money. And so I feel confident that this is indeed the answer that they're looking for, 130.5 pounds.